In this problem, we have to use the curve fitting features of some device, either your graphing calculator or Excel. I'm going to use Excel, so you can refer back to the link that I shared earlier about fitting data with a line, and we're going to follow mostly the same steps here, but I'll go through them, and hopefully you can translate this into whatever version of Excel you have. So the first thing we want to do is put our data into Excel. So the column here we have X and I. X is the age, midpoint age, and then the I is the income, median income for that group. And you can see I just typed that into Excel. I'm now going to select my data, and I even gave it headings so that'll translate as labels, which is nice. And choose charts. I'm going to insert. I have to scroll down here. I'm looking for a scatter plot all the way down to the bottom. So mark scatter plot, none of the lines fitting in between, just the points. And you can see that we get a plot that that puts the ages on the x-axis and incomes on the y-axis. So let me put that there. Oops, as far as I can. And you can see that our data looks like it would fit on a parabola. That's our idea that we're going to try to fit this with a second degree polynomial. So the way I do that is select one of the data points. You'll notice they all get selected then. And then just right click on one, and add trend line is going to be one of my options. So these are the same steps that we did before for fitting a line, but now when I'm under type, I don't want to pick a linear regression. I want to use a polynomial regression. And I want to make sure that it's set to be order 2. Order 2 polynomial means it has an x squared and it has its highest degree term, which means it's a quadratic polynomial. Now before I say OK, I want to also set the option to display the equation on the chart, because the questions I'm going to get asked are about this equation. So I want to make sure I have that available. So now I say OK. You can see my equation here. I'll move it where I can see it. And so the black line indicates the parabola that was graphed that fits these points as well as any polynomial can. And then this is the equation of the curve that you see in black. I know from having done this problem once before that it actually asks me for these 3 coefficients of the polynomial each to 3 decimal places. So I'm going to have to change a setting to make that happen. So again, just right click on this label and you'll see that you have format trendline data. And so we're going to say the numbers in this label should be displayed to 3 decimal places. And again, I don't have to do that all the time. I just know in this MyLabs Plus question that that's going to be the way it asks. So you see each of the coefficients is given to that degree of accuracy. So in my problem then, first thing it asks me is what do your points look like? And that's a pretty easy question. It looks like a parabola facing downward, and so that's part A. It asks what type of relationship exists. This is a quadratic relationship, parabola shape. And the A here, remember this is the coefficient of the x squared term. We expect the A to be negative because we expect this to be a downward concave parabola. Because we've already sort of answered the question in advance here, I know for a fact that the A is negative. In fact, I know it's negative 46 point something from my calculation, but just the shape of it tells us that that number was going to be negative. Then it says find the best fit model, and so that's what I've done already. That's why I knew what it was going to ask, because I've already done it. I'm just typing these 3 coefficients in from what Excel tells me, and it's going to want each one to 3 decimal places. Next, it's going to ask what the age where you earn the most income is and what that maximum income will be. Back in terms of our graph, the age where my income is maximized is the x-coordinate of this parabola. The income level for that age is the y-coordinate of this parabola. So this question in the homework is really just asking for the x and y coordinates of the vertex of this parabola. And that's an easy question because I have the equation of the parabola. Let me make this a little bit smaller so I can see it. I have the equation of the parabola sitting right in front of me. So I could even use Excel as my calculator. You can certainly just do it on your own calculator. But remember, my x-coordinate of my vertex is negative b over 2a. So I can type negative 4409.695 divided by 2a will be 2 times negative 46.4 6.537. So here I'm just doing negative b over 2a. If you've never used Excel as a calculator before, all you have to do is start your expression with the equal sign, and that tells it that this is going to be a formula, and then Excel will evaluate it. So the question asks for the age to the nearest tenth. The x-coordinate of this parabola looks like it's 47.4, and so the x-coordinate is the age. So at age 47.4, this model is predicting that you're going to be at your highest income level. Now the y-coordinate at that level is going to come from plugging the x-coordinate into the formula. So again, I can use Excel as a calculator, or you can use your own calculator. But if I just type negative 46.537 times 47.4 squared, I'm just using the x that I gave earlier, plus 4409.695 times 47.4 minus 57770.475, and I get, ooh, that's not right. Oh, negative. I lost my negative sign. Negative 46.537. So I get an income level of $46,691.92 if I round to the nearest dollar. And so that's what I've typed here. So my income level. So this is the x-coordinate of our vertex. This is the y-coordinate of our vertex. The x-coordinate is the age where the maximum income occurs. The y-coordinate is that maximum income. The last question in this problem just asks which picture looks right, and it's hard to imagine answering this question wrong because it's going to be the one that has the same data on it. So only one of these actually matches the data. It's part C here, but you'll have the picture right in front of you the whole time.